Hi, my name is D. Leelasha Kumar. Today's seminar about counters, a comprehensive overview of counter types, operations, and applications. Classification of counters, types of counters, application and IC, asynchronous and synchronous counters, special counters, advantages, limitations, and conclusion. What are digital counters? Definition: a digital counter is a fundamental sequential logic circuit designed to store and count the number of times a specific event or process occurs, typically in response to a clock signal. Core operations: timing synchronous with clock signals, sequence state transistor in a specific order, counting, reporting counters in binary or BCD. Classification of counters: asynchronous counter, synchronous counter. Sequential clocking: only the first flip flop receives the external clock pulse. Synchronous clocking: all flip flops share a common clock signal. Ripple effect: change of state propagates through the counter. High speed parallel clocking eliminates cumulative propagation delay. Slower speed cumulative propagation delay limits maximum frequency. Complexity requires additional combination logic for control. Asynchronous ripple counter. Definition: As an asynchronous counter, also known as a ripple counter, is characterized by a sequential clocking mechanism where flip-flop are not triggered simultaneously. Key characteristics: sequential clocking: only the first flip-flop receives the external clock pulse. Ripple effect: change of state propagates through the counter one flip-flop at a time. Simplicity: generally similar to design and construct due to straightforward arrangement. Slower speed cumulative propagation delay limits maximum operation frequency. Ripple counter operation and limitations. Operations: sequential clocking: only first flip flop receives external clock pulse. Output of flip flop serves a clock input for next in flip chain. Ripple effect: state changes propagate through counter one by one. Limitations: cumulative propagate delay accumulate through chain. Momentarily unstable output as clock ripples through flops. Timing glitches limit maximum operating frequency. Synchronous counters. Working principle: in a synchronous counter, all flip-flops are connected to the common clock signal, ensuring that their state changes occur simultaneously. All flip-flops change state at the same time. Uses combinational logic to control toggle inputs. Circuit implementation: for a 4-bit synchronous up counter using JK flip-flop, Q0 always to trigger with each clock pulse Q1. Toggles only when Q0 is high. Q2 toggles when both Q0 and Q1 are high. Synchronous counter advantages: high speed operation. Parallel clocking eliminates cumulative propagation delay, allowing operation at much higher frequencies. Eliminated cumulative delay. No ripple effect means all state changes occur simultaneously, ensuring stable output. More reliable operation. Concurrent state changes provide predictable and reliable performance in high-speed digital systems. Types of counters: up counter, down counter, up and down counter. Up counter increments stored value by 1 with each clock pulse, counting in ascending sequence. Down counter decrements stored values by 1 with each clock pulse, counting in decreasing sequence. Up and down counter combines functionlets of both up and down counter with a controlled output to derive counting direction. Special counters, decade counters. Definition: a decade counter, also known as a mode 10 counter or BCD counter, is designed to count through 10 distinct states and then the reset equal to 0. Key features: counts decimal digit 0 to 9, resets to 0 after reaching 9, provides binary representation for each decimal digit BCD. Application: digital clock, frequency meters, display systems, digital systems. Special counters: Ring and Johnson. Ring counter: a specialized sequential circuit formed by connecting the output of the last flip-flop in a shift register back to input of the first flip-flop, creating a circular arrangement. Characteristics: types typically include with a single 1 bit circulating through the flip-flop, while other flip-flops holds the opposite state. An n flip-flop ring counter has n unique states. Mode n counter. Johnson counter: a modification of ring counter where the invented output of the last flip-flop is fed back to input of the first flip-flop. Characteristics: produce 2n unique states for an n flip-flop counter, similar to a gray code sequence where only on 1 bit changes at a time generates specific waveforms useful in timing sequence. Application of counters: standard applications: digital clocks, frequency counter, timer, event counter, memory addressing, state machines. Technical and emerging applications: data equalization, frequency dividers, ABCDs, IoT devices, automation, defense systems. Counter ICs: common counter ICs, counter range, clock frequency, power consumption, output format. Advantages and limitations. Advantages: simple design with straightforward cascade arrangement, lower component count resulting in low cost. Limitations: propagation delay effects, maximum operating sequence, sequential triggering intrudes through issue at high. Synchronous counters. Advantages: faster operation with simultaneous state change, no cumulative propagation delay or ripple factor. Limitations: more complex design requiring additional logic gates, higher cost due to increased component count. Summary and conclusion. Key takeaways: counters are fundamental sequence logic circuit using flip-flops to store and counts in response to the clock signals. A synchronous counter offers simplifying but suffer from propagating delay, while synchronous counters provide faster, more reliable operation. Various counter types: up, down, up and down. Special services. Specific application in digital systems. Counter find essential applications in digital clocks, frequency measures, industrial automation and advanced control system. Counters are fundamental building blocks in digital electronics, essential for counting events, timing operations and generating sequence in modern technology. Thanking you.